This conference will now be recorded.
Okay, good afternoon, students. Today we are going to discuss about what are the objectives of reactive power in power system network. See, generally, if you want to design the power system network, we should mainly concentration on losses. So, how to we are always keep remembering that how we can reduce the losses and how we can send the power to the load with perfect manner. So, at the same time, we need to be used that how we can stabilize the reactive power. So that is the thing. So it means that how the reactive power is involving while delivering the power to the load, and how the reactive power is involving to reduce the blackouts. So these are the things we are going to discuss in today's class. Let's move on to the topic. So this is the topic here. That is importance and objectives of reactive power in power system network. See, first of all, why we are giving the this much of importance to the reactive power means it means that well demanding that it will increase in the demand on the load side. Why? Because our load side is keep on going to be increase the network, like increase in the industrial utilities and domestic areas. Due to this increasing in this power requirement, the reactive power requirement is also increasing. So that's why we are giving more importance to the reactive power. So then only we can deliver the power to the load with purity of power. Now, by maintaining why we are giving the importance means by using the reactive power, by controlling the reactive power, we can make that stability and reliability of the electrical power system. So this is the two factors which gives that how much of efficiency happened having this power system, and this requirement is maintaining that power management. It means that power management says to reduce the blackouts, power cuts and losses and damages in the load side, and it required that to generate the more efficient, and it is completely belongs to that reliable and cost effective. Suppose if you maintain the reactive power in the perfect manner, then we can give that perfect pure power to the load. Then there is not possible to any damages occur in the load side. So we can reduce the cost effectively also. Next. So, how we can maintain this type of reactive power controlling means by using different methods. So generally, in AC systems, we are using the FACS devices, that is flexible AC transmission system. So, the name itself indicates that when we are using the FACS devices in the system, that the power transmission should be flexible. So flexible in the sense of there is not possible any deviation in the reactive power. Then we can send the real power to the load by using reactive power and clean. Now, and by maintaining the reactive power, the flexible is not only that we can maintain that high power factor, and we can reduce the transmission losses also. That's why the reactive power plays a crucial role in the power system network. So the first thing is it will reduce the losses. Second one is it will increase the power factor. And third one is it will reduce that losses, that is damages happen in the load cell. So it is cost effective. So these are the three reasons shares that how we are giving that importance to the reactive power. Next. Generally, an AC system having the two types of powers. One is real power and reactive power. In that, real power is used for that useful for means generally we need only real power, but reactive power is an imaginary power, and its function is it will only support the real power to deliver from source to load. And this reactive power, what is the function means it is not useful for but simply moves back and forth in the power system. It is a byproduct of AC system, and it should be produced from that inductive and capacitive, right? So and this reactive power, how it will be happen is, if there is any phase difference between the current and voltage, then we can the reactive power will be occur. So already we discussed it, right, by using the waveform. So waveform in the sense, when the current and voltage within the same phase, then we can get only real power. If there is any deviation happen in that in the power factor, then there is a presence of reactive power, and its units is VAR. Next, see here, this is the diagram represents that how much of reactive power we support to deliver the power. See we have the two diagrams, right? This is the diagram represents that the real power flow without power factor, without reactive power. See, if it is if there is no reactive power support here, the flow of power is not possible. We can't able to send the real power to the load. Now, with the support of reactive power, we can easily send the real power to the load, and this representation is given by this diagram. So this is the diagram represents that without reactive power support, and this is the diagram represents that with the reactive power support. Next, let me see that what are the objectives of reactive power. When the compensation is provided, actually we are providing the compensation in two ways. One is in transmission system, another one is in load system. Now, when the compensation is provided directly across the terminals of the load, then it is called as load compensation, right? It is the process of, so what is the need of compensation? What is the main purpose of compensation is? It is the process of management of reactive power to provide and improve power quality supply. So when we maintain this type of reactive power, then only we can manage that real power, and we can improve that the supply, right? So that is the objective. And in load compensation, the adjustment of reactive power is done across that respective load. So if we observe that any substation, there be a huge bulk amount of capacitor banks. So what is the main intention of capacitor banks? When there is any deviation happen in the reactive power, it will boost up them. So this is called as load compensation, and we are providing the compensation across the individual load terminals. Individual load terminals. Load means it's not a single house. Okay, now it is some area. In that area, it is coupled to the substation. In the substation itself, they are providing the compensating devices, and it will provide the reactive power to the load. Next, these are the 5 objectives why the reactive power is involving vital role in the power system network. The first thing is better voltage profile. Second, load balancing. Third one is power factor correction. Fourth one is overcome from electrical blackouts, and fifth one is proper working of various devices or machines. So let's see a better voltage profile in the sense, without any deviation in the phase shifting of voltage and current. So then only we can maintain that better voltage profile. And next thing is load balancing. So load balancing in the sense, so if there is any unbalanced condition is occur, so generally the unbalanced condition is happen in the load side. But if there is any unchanged loads are on or off, so based on that, the load will be suddenly increase or decrease. So it makes that load balancing, and this situation and this condition makes that the deviation in the power factor, so that should be minimized by this reactive power compensation. And next, third one is power factor correction. Already we know that when the electrical device having that nearer to the unity power factor, and it gives that accurate results, but it is not possible. So approximately we are getting that maximum 0.8 power factor. So it means that the power factor act as a vital role in the performance of a device, and it can be maintained by using that reactive power compensation. Next, fourth one is overcome from electrical blackouts. So electrical blackouts in the sense, it is a power cut as along with 1 week or 10 days like that. So that is called as electrical blackouts. In the olden days, there are in many areas there are electrical blackouts was happened because of this sudden load demand. When the load demand is suddenly increased, and it is completely block out some say area in within a week or 10 days like that. So we can overcome from this type of fault by using the reactive power compensation. Next, fifth one is proper working of various devices and machines. See, already we know that the electrical device, that is what we are using in the load side, the device like refrigerators, TV, washing, whatever it may be, it is completely based on that to the quality of voltage. So that's why they have mentioned that the capacity and the rating of the device in terms of stars, 3 star, 4 star, 5 star. So it means that when the stars is increases, it means that the power factor also increases. So it means that device should be consuming the less amount of power. And this type of possibilities and this type of objectives only made by this reactive power compensation. Let me see that one by one. The first one is voltage profile. See, how we can maintain the voltage profile is generally the power system having that different types of voltage levels. Suppose if we take the generating station, there are certain there is a voltage level different when compared to the transmission line as well as the distribution system. So in the three complete power system, the voltage level should be differ. So generating, if you see the generation, it is 11 kV, 11 megawatts like that. So 11 kV, 33 kV like that. Now when we transmit, when we this much of voltage to transmit there, then it should be increases to 110 kV, 400 kV, 200 kV like that. And again it should be stepped down and we are delivering to the load. So it means that here the voltage levels consumed by different areas, it sometimes it goes low and high. Then based on this voltage levels, there are suddenly deviation happen in the voltage profile. Now, so to provide the better power supply, we need to be maintain that voltage. If there is any deviation is happen, that we have to maintain that deviation within that plus or minus 5% of rated value. Then only we can maintain the voltage profile in perfect manner. And this can be this plus or minus 5% voltage profile we can make by using that reactive power control. Okay. So మనకు frequency deviation కానీ voltage ఏది తీసుకున్నా కానీ plus or minus 5% deviation ఉండాలి. Okay. If it is exceeded or decreased, then there is chances to get the problem. Next one is load balance. So it is it is main important in the power system. Why? Because if the three-phase system is balanced, then only we can get that reactive power compensation is possible. If there is any unbalanced condition is there is no voltage and current should be possible to deliver the load. Already we discussed in the power system analysis, balanced condition, balanced uncompensation, balanced unbalanced conditions. Okay. So in three-phase system, we need to always maintain that balanced condition. Okay. So this should be happened by that reactive power compensation. If we are not providing this type of compensation in the load side, that is in power system, there is a chances to get that unbalanced condition in a three-phase system, and it makes that huge damage in the power network. So that is the thing, that is the importance of reactive. Next, power factor correction. So power factor we can see in the way of economic operation. So economic operation means in some let me take two devices. If refrigerator and washing machine, if it has that the refrigerator has that 4-star machine and that washing machine is 3-star machine. Now when compared to these two devices, the washing machine which has the 3-star and it has the less amount of power factor, and which device has the low amount of power factor and it drags that more power. So అప్పుడు ఏమవుతుందంటే దాని యొక్క రెగ్యులేషన్ అనేది చేంజ్ అవుతుంది. సో ఇట్ విల్ మేక్స్ దట్ పూర్ వోల్టేజ్ రెగ్యులేషన్. And this is this point which is related to the economic operation, which if the device has the more power factor, then it should be operating in an economic way. Generally the power factor should be maximum in the electrical devices that is using in the load side. It is approximately 0.8. So this is the maximum we can make that power factor. Next, overcome from electrical blackouts. So just now I said, right, in olden days, like previous 10-15 years back, So several electrical blackouts was happened like that in France during 1978, northeast countries in 2003, many parts of India during 2012, and this much of blackouts generally this will happen in naturally and accidentally. So naturally in the sense when floods and so like that they came means at that time the power entire should be blackouts, and that is naturally happen. In artificial happen means when the load is suddenly increased or decreased, at that time the blackouts will be happen, and this type of problem will be faced on some during summer seasons, right? So why this type of blackouts will happen is because of insufficient reactive power on the electrical power system. So when it will happen means when there is when there is a load should be under should be changed from low to high to low, suddenly change, and it makes that insufficient reactive power in the system, and it makes that blackout situation. Now this is the rise because that demand of reactive power is unusually high due to low long distance transmission. So this is the one of the factor. So if the distance between that generation and the load, if there is a heavy long, then there is chances to get that lack of reactive power. It is one of the reason. Now this ultimately leads to that shutting down of various equipment and generation units due to low voltage. When this type of situation is happen, they only one choice, we have to be switch off that particular load. So if you want to avoid this type of situations, we need to be maintain the reactive power by using the reactive power compensation. When we are using that this compensation, the sufficient amount of reactive power must be present in it. Next, proper working of various device machines. Generally, already we seen that power factor, right? So power factor is related to the economic operation. At the same time, if our load set we have a different, not only load set and entire power system we have different electrical devices. Majorly we have transformers, motors, and generators. Now, these three devices are most probably require the reactive power. Why? Because it will produce the magnetic flux. So already said these three devices are synced with reactive power. Why? Because these three devices will produce the magnetic flux. And this is the because of generation of magnetic flux, it is necessary for this device to do useful work. That is, we have to provide the real power for working that. In that, so here I will show you one diagram after this. In that, how the reactive power, how the real power is useful, giving that useful work to that device, electrical device. Then you can get idea about this. Right. So this is the diagram represents that without providing reactive power and with providing reactive power. Here we can provide the reactive power by using the capacitors. Right. See here. This is the diagram represents that without capacitor, and it is the diagram represents that with capacitor. If you are using the orange color represents the reactive power, and this blue color is active power, and green color is available of active power. Now, if we are not using the capacitors here, there is not available of active power. So active power in the sense real power. Okay, now? So there is always we need to be maintain the real power is available. Why? Because we don't know that what will happen in the load side. Sometimes it will be suddenly increase the load and suddenly decrease the load. So based on the situations, we need to be always available active power in the sense. Now, if there is no active power is available, there is no use of to maintain the reactive power. You know, that's why we need to be always available of the reactive power. Then the real power. The reactive power should be compensated by the capacitors. So already you seen the fact device, right? Every fact device is a combination of capacitors. Why? Because here the capacitor and reactor will make that reactive power compensation. So that's why those devices having and coupled with that capacitors and reactors. So this is about abilities of reactive power. You know, right. So this is about today's class. Actually, after this class, I want to tell you that how to prepare the power system analysis, right? So after this class, you may get you have the class maybe or may not be because you are going to write the exams, right? So that's why after this class, I'm going to explain that how to study that according to the syllabus. Yeah, that I am going to explain. and before that most of them didn't send that receipt. Okay, ఇంకా చాలా మంది నాకు రిసిప్ట్ సెండ్ చేయలేదు. సో జస్ట్ ఐ విల్ టెల్ యూ their name and just send me before today itself. సో మీకు ఇంటిమేట్ చేస్తాను ఎవరెవరని చెప్తాను. సో 202 and 203. So who is it? 203? Lakshmi Devi, right? Lakshmi Devi is there. 203. No, she is not there. Next to 204, Satish. Next 205. Who is 205?
Seriously, sir.
Oh, okay, ask her whether she is writing, where she is writing. Okay, na? So మీరు ఎక్కడ రాయాలో నాకు డిక్లరేషన్ ఫామ్ మెన్షన్ చేయాలి, ఎందుకంటే మాకు అది ఇస్తేనే మీకు మీరు కోరిన కాలేజీలో ఇస్తారు, లేదంటే మీరు ఖచ్చితంగా మన కాలేజ్ వచ్చి రాయాల్సింది. ఓకేనా, ఇన్ఫార్మ్ చేయండి. తర్వాత 206. Who is 206?
Ashok, sir.
అశోక్ ఉన్నాడు. అశోక్ అశోక్ ఓకే. నెక్స్ట్ 208. 208 కూడా సెండ్ చేయలేదు. శివప్రసాద్. 209 మానస. 210. సో 210 ఓకే. నెక్స్ట్ 211 భాగ్యలక్ష్మి. భాగ్యలక్ష్మి కూడా చేంజ్ చేయలేదు. 212. 214. 214 who is this? కృష్ణవేణి. సో కృష్ణవేణి గురించి చెప్పండి. మా అమ్మాయి డిక్లరేషన్ ఫామ్ పెట్టలేదు. ఓకేనా, సో మీరు డిక్లరేషన్ ఫామ్ ఖచ్చితంగా పెట్టాలి. ఖచ్చితంగా పెడితేనే నేను ఆ కాలేజ్ అనేది ఎంటర్ చేస్తాను. మీరు కనుక అది చేయలేకపోతే దేర్ ఇస్ నో యూస్. యూ షుడ్ హ్యావ్ టు కమ్ టు అవర్ కాలేజ్, దెన్ యూ హ్యావ్ టు రైట్ ద ఎగ్జామ్. ఓకేనా, సో నాకు ఈవినింగ్ లోపల మ్యాక్సిమం సెండ్ చేయండి. సెండ్ చేసిన తర్వాత నాకు ఇన్ఫార్మ్ చేయండి. జస్ట్ మీరు, ఎందుకంటే మీ నెంబర్స్ నా దగ్గర ఎవరు లేవు. ఓకేనా, సో చేసిన తర్వాత కాల్ చేయడం లేదా ఇన్ఫార్మ్ చేయడం ఏదో చేయండి, ఎందుకంటే ఇట్ ఇస్ డిఫికల్ట్ టు ఫైండ్ దట్ హూ ఈస్ సెంట్. ఓకేనా, లేదా మీ పేరు అనే మెన్షన్ చేసుకోండి. సో అమ్మాయి కృష్ణవేణి చెప్పండి అమ్మా. నెక్స్ట్ 215 వెంకటేశ్వర రెడ్డి. సో హీస్ నాట్, హీ డిడ్ సెండ్ దట్. 216 వినీత. వినీత ఉందా? సో ఎంఐ కూడా లేదు. సో ఎంఐ ఓన్లీ డిక్లరేషన్ అని చెప్పి పెట్టింది. సో పీజీ రిజల్ట్ పెట్టలేదు, ప్లస్ సబ్జెక్ట్స్ ఫామ్ పెట్టలేదు. ఓకే, ఇన్ఫార్మ్ చేయండి అమ్మా. సో అమ్మాయిలకు వచ్చేసి మా పవన్ మీరు చెప్పండి, అబ్బాయిలకు వచ్చేసి ఎవరైనా నువ్వు ఇన్ఫార్మ్ చేయి. ఓకేనా, right? So I will tell you that how you have to prepare the subject PSC. మీకు యాక్చువల్గా 5 యూనిట్స్ మామూలుగా అయితే మీకు 5 యూనిట్స్ ఆల్రెడీ క్లాస్లో చెప్పాం కాబట్టి సో మేబీ మీకు కొంచెం డిఫికల్ట్ ఫీల్ చేయొచ్చు అంటే వెన్ కంపేర్ టు ద లాస్ట్ 3 యూనిట్స్ 2 యూనిట్స్ కొంచెం పెద్దవి కాబట్టి ఫస్ట్ మీరు ఏం చేస్తారంటే ఫస్ట్ రీడ్ స్టడీ దీస్ 3 యూనిట్స్ యూనిట్ 3 యూనిట్ 4 యూనిట్ 5. In that, for our studies one, you had to concentrate on Gauss seidel method, algorithm, and flowchart. Okay, na? So maximum they will ask this these two questions, algorithm or flowchart, and just derive that load flow equation. These three is enough, and just practice 2-3 problems. So that is enough from the first third unit. At the same time, fourth unit. So there are two methods are there: rectangular coordinates and polar coordinates. So in Newton option method also, they may ask algorithm and flowchart. So this is the one choice is you have to be prepared that the Newton Rational method in the form of rectangular coordinates and polar coordinates. Okay, na? So these 4 questions is enough from the unit 4. Next unit 5. In that unit 5, there are different questions are there, like swing equation. So swing equation is there, right? Swing equation, equal area criteria, and equal area criteria is used to find that critical clearing angle and critical clearing time. Okay, now. So this is the most important question. One is single equation and the equal area criteria. And just see that the power system stability limit. Okay, now. So first, read these 3 units, unit 3 and 4, 5. If after these 3 units, just come to the unit 1 and unit 2. If you have faced any difficulties to understand, just inform me. I will make that video and send to you. Okay, now? Like if you see this first unit, so there are only problematic parties. The first thing is that is formation of Y bus. Okay, now? So up to this formation of up to this, it is a problematic concept. So how we can find that incidence matrices, bus incidence, branch, cut set, loop, like that, and formation of Z bus. After that, addition of branch, addition of link. It is a completely there is so when if you divide this unit 1 2 parts. So first unit for so part A you will get incidence matrices and derivations for bus admittance, loop impedance, bus admittance, branch admittance, and loop. So Y bus, Y branch, and Z loop. So there are 3 derivations are there. Okay, now, this singular transformation, non-singular transformation. So this is completely this is the part we will get the questions from part A. In part B, that is addition of branch, addition of link, derivation, and problems. So these are the just divide that parts. Based on that parts, you have to study that. If while studying, if you are difficult to understand any topic, just inform me before itself. So why? Because I have only 1 week time, so I have to prepare video set. So before Sunday, okay, you can send to me. So what are the topics you need to be videos or revision? Based on that, I will prepare that. Okay, na? At the same time, secondary. So మీకు already so నేను ఫస్ట్ యూనిట్ వచ్చేసి ఇన్సిడెంట్స్ ప్రాక్టీస్ పైన ఒక వీడియో చేస్తాను. So incidence matrices, how we can find a bus incidence, augmented bus incidence, branch, that is a K matrix, branch path incidence matrix, cut set, loop, augmented cut set, augmented loop. Based on that, I will make that one video. After that, by using this incidence matrix, how we can find that Z bus. Okay, na? Z bus ఎలా ఫౌండ్ చేస్తాం? ఆ Z bus ఫౌండ్ చేయాలంటే we need to derive these 3 derivations. Okay, na? So Z bus is equals to, Y bus equals to what you will get A Y A transpose. Okay, na? So ఈ విధంగా మనం కప్పాలి. సో ఈ ప్రాబ్లం చేయాలన్నా you need to know that incidence matrices. So దానిపైన ఒక ప్రాబ్లం చేస్తాం. If you come to the second unit, it is a huge topics are there. In that up to symmetrical components. So up to from here to here, it is a part one part. from here to here. It is first part A and part B. In part A, you will get that MVA calculation, that is per unit values of calculations. Suppose they will give one network and you have to convert that network to that reactance diagram or impedance diagram. For converting that, you need to find that all devices which are connected to the network in per unit value. So we have the different formulas, right? Okay, first of all, we need to assume that base values. After that, we have to use the per unit value for generator. So there is a difference for transmission line. Transmission line different ఉంటుంది తర్వాత ట్రాన్స్ఫార్మర్ సో వేర్ ఇస్ ద ట్రాన్స్ఫార్మర్ ఇస్ దేర్ we need to be observe the primary voltage and secondary voltage. Okay, so primary voltage ఎంత ఉంది, secondary voltage ఎంత ఉంది, step up or step down, so you need to be change the voltage level. Based on that, you had to solve the problem. And when compared to the part B, it is symmetrical components. So symmetrical components in sense positive, negative, zero sequence components. In that there are problems based on the positive, negative, and zero. Okay, now so here there is a matrix 1 1 1 1 a square a 1 a square. So based on this matrix, we are going to derive this equation. Okay, now so a and the one angle 120 degrees. A is equals to 1 angle 120 degrees and A square అంటే 1 angle 240 degrees. ఓకేనా, సో ఆ విధంగా తర్వాత 1 plus A square equals to ఏమవుతుంది. సో that is the formulas we are going to discuss here. And in that, after that, there are two topics are there: symmetrical faults and unsymmetrical faults. And we did the different derivations: line to ground, line to line, double line to ground, with impedance and without impedance. Okay na? So that is the topic we need. So మీరు కాన్సన్ట్రేషన్ చేయాల్సింది ఎక్కువ యూనిట్ 1 యూనిట్ 2 పైన. ఎందుకంటే మీరు ఇచ్చిన క్వశ్చన్ ఖచ్చితంగా మీకు ఈ 2 యూనిట్స్ పైన క్వశ్చన్స్ అటెండ్ చేయగలిగితేనే యూ విల్ గెట్ ద గుడ్ మార్క్స్. కానీ మీరు ఫస్ట్ యూనిట్ సెకండ్ యూనిట్ ఏ ప్రాబ్లం ఇచ్చినా ఏ క్వశ్చన్ ఇచ్చి అటెండ్ చేసేలాగా ప్రిపేర్ అవ్వండి. ఇఫ్ యూ హ్యావ్ ఎనీ డౌట్, ఇఫ్ యూ హ్యావ్ ఎనీ డిఫికల్ట్ టు అండర్స్టాండ్, జస్ట్ ఇన్ఫార్మ్ మీ. ఐ విల్ మేక్ వీడియో అండ్ విల్ సెండ్ యూ. ఓకేనా, రైట్. సో do you have any suggestions అంటే ఏమైనా అంటే ఎలా ప్రిపేర్ అవ్వాలి, ఏమైనా డౌట్స్ ఉన్నాయా? Do you have any doubts to prepare, how to prepare this subject? లేదు, క్లాసెస్ కావాలన్నా క్లాస్ తీసుకుంటాను. సో క్లాసెస్ తీసుకుంటే ఇట్ ఈస్ టైం వేస్ట్ ప్రాసెస్, రైట్? ఓకేనా, సో క్లాసెస్ వద్దులేండి. మీకు ఏదైతే టాపిక్ డిఫికల్ట్ ఉంటుందో ఆ టాపిక్ సెండ్ చేయండి. ఐ విల్ మేక్ ద వీడియో. ఓకేనా, అయితే మొత్తం సిలబస్ చేసేంత టైం లేదు. సో జస్ట్ మీకు ఏదైతే డిఫికల్ట్ అనుకుంటుందో ఆ టాపిక్స్ చెప్పించాలి.
సార్
చెప్పండి.
అంటే ఇప్పుడు ఎగ్జామ్స్ కి ముందు ఈ దసరా హాలిడేస్ లో మీకు ఏదైనా ఒక రోజు ఫ్రీగా ఉన్న రోజు అంతలోపు మేము చదువుతాం సార్.
నేను ఎప్పుడైనా చెప్తాను, నో ప్రాబ్లం. మీరు
అంటే మేము ఓకే సార్, మేము చదవడం స్టార్ట్ చేశాక డౌట్స్ వస్తాయి కదా సార్, ఇంకా ఎవరం అంతగా స్టార్ట్ చేయలేదు. చేశాక వచ్చిన అన్ని ఆ క్లాస్ లో మీరు మాకు క్లియర్ చేస్తే కొంచెం యూజ్ అవుతుంది సార్. అంటే అందరికి సేమ్ కామన్ డౌట్స్ కొన్ని ఉంటాయి.
అదే మీరు ఎంతసేపు ఎంత అయినా కానీ మీరు ఆ వీక్ లోనే కంప్లీట్ అయిపోవాలి.
ఓకే సార్.
ఫస్ట్ మీరు ఏం చేస్తారంటే యూనిట్ 3, యూనిట్ 4, యూనిట్ 5 చదివేసేయండి. నేను ఆల్రెడీ యూనిట్ 1, యూనిట్ 2 పైన మీరు మీకు ఖచ్చితంగా ఒక ప్రాబ్లమ్స్ వీడియో చేస్తాను, కొన్ని ప్రాబ్లమ్స్. తర్వాత ఏమైనా డౌట్స్ ఉంటే అప్పుడు డిస్కస్ చేసుకుంటాం, ఎందుకంటే టైం వేస్ట్ చేసుకోవాలి. ఓకేనా?
ఓకే సార్.
సరే, ఇంకేం డౌట్స్ లేవా? రైట్. నెక్స్ట్ పిఎస్పి ఎలా? సో పిఎస్పి ఆల్రెడీ కొన్ని టాపిక్స్ డిస్కస్ చేసుకున్నాం. సో తర్వాత మనకు టైం లేదు. సో ఆల్రెడీ మీకు టెక్స్ట్ బుక్ పంపించాను కదా, అందరికీ ఉందా టెక్స్ట్ బుక్? సో మీకు సాఫ్ట్ కాపీ టెక్స్ట్ బుక్ పంపించాను. ఓకేనా, సో అది పవర్ సిస్టమ్ ప్రొటెక్షన్ వచ్చేసి మీరు ఓన్ గా చదువుకోవచ్చు, నో ప్రాబ్లం. ఎందుకంటే ఆల్రెడీ మనం పిఎస్సీలో చెప్పేటప్పుడు మీకు ప్రొటెక్షన్ గురించి చెప్తానే వచ్చాను. సో వాట్ ఇస్ ద మెయిన్ ఇంటెన్షన్ ఆఫ్ ప్రొటెక్షన్ అండి. తర్వాత అండ్ ఇట్ ఈస్ సిమిలర్ టు దట్ ఎలక్ట్రికల్ మెజర్మెంట్స్. ఓకేనా, as I think you can easily understand. If or also దాంట్లో కూడా మీకు ఏమైనా డౌట్స్ ఉన్నా కానీ I will take the classes and I will make the videos. Okay na? Okay students, this is about today's class. Okay, now. So I don't want to waste time. So just I'm complete this class now. Okay, now. So మీకు ఏమైనా డౌట్స్ ఉంటే నాకు మెసేజ్ చేయండి లేదా కాల్ చేయండి. So I'm going to end this class now. Thank you.